So our learning target is to use the triangle inequality theorem. So we need to learn the triangle inequality theorem before we can use it. And here it is on page 360. The triangle inequality theorem says the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. The sum of the lengths of any two sides must be greater than the length of the third side. So, no matter what numbers you're given, if you add two lengths together, that result is always greater than the length of the third side. And look, it has to work that way. If we have that as a triangle, or that as one side of a triangle, and if I then draw in the other two sides, when I take this apart, see how the two sides combined give me a length greater than the third side? It always happens. And look, if they weren't greater, if they were just equal to even, that won't work. Because if I shorten that one down so that the two lengths, the two sides are the same length as the third side, well, look what happens when I try to make a triangle out of it. Oops, it doesn't connect. Okay? So the sum of the lengths of any two sides must be greater than the length of the third side. So that gives us three inequalities. All right? These two sides added together are greater than the third. This different pair of sides added together is greater than the third. And then the last pair greater than the third. Okay? You guys with me? All right, let's do some examples. So turn to page 362. Is it possible to form a triangle with the given side lengths? If not, explain why not. You don't have to explain why not, because there's only one way to determine this, and it's by using the triangle inequality theorem. So if the answer is yes, it's because of the triangle inequality theorem. If the answer is no, it's because of the triangle inequality theorem. So you don't have to write an explanation. So for number one, we need to make sure that no matter which two lengths we add together, it's always greater than the length of the third side. So, is 5 plus 7 greater than 10? Yes. Is 7 plus 10 greater than 5? Yes. Is 5 plus 10 greater than 7? Yes. So is it possible to use segments with those lengths and make a triangle? Yes. In fact, once I'd done that one, didn't I kind of know the others were going to work? If I add the two shortest lengths and it's greater than the longest side, well, then the other two are going to work also. They just are. Yeah. All you got to do is put yes. Okay. Number two, is 3 plus 4 greater than 8? No. So that's not true, so we say no. No need to check the others. If one of those inequalities doesn't work, then you can't make a triangle out of those lengths. Now, number three, they're playing tricky here. They didn't put them in order from smallest to largest, but that's okay. Is 6 plus 14 greater than 10? Yeah. Is 6 plus 10 greater than 14? Yep. Is 10 plus 14 greater than 6? Yeah. So, yes. In fact, as long as I can add the two shortest and get a result greater than the longest, it's going to work. Let me ask you, we'll call this one 3B. Okay? 7, 3, and 10. Will those three lengths make a triangle? Is 7 plus 3 greater than 10? No. No. So it's not good enough for the two short ones to add up to be equal to the third one. It's got to be greater than. Okay? So far, so good? All right. When they give us all three sides as numbers, this is easy peasy, wouldn't you say? At least you would if you'd ever heard that expression. So, number 4. If the measures of two sides of a triangle are 5 yards and 9 yards, what is the least possible measure of the third side if the measure is an integer? Question? We have one vote for 5. Another vote for 5. Lots of votes for 5. All right. My guess is you worked it out this way. You thought of 5, 9, and let's say x as the lengths of your three sides. So you know that 5 plus 9 has to be greater than x. So in other words, 14 has to be greater than x. And that doesn't really tell us anything about the least possible measure, does it? Right. So we could try this, though. We could do 5 plus x. That has to be greater than 9, doesn't it? So x has to be greater than 4 when you subtract 5 from both sides. That's telling us something. That helps us with the least. We know that 4 can't be it, can it? Because 4 is equal to 4, not greater than 4. And doesn't it also have to be true that x plus 9 has to be greater than 5? Well, that gives you x is greater than negative 4. Well, I knew we weren't going to get a negative side length, didn't you? So this is the one that really answers the question, isn't it? The others are true. That's the one that really answers the question. Now, they did say that the third side has a measure that's an integer. So it turns into what's the smallest integer greater than 4? And y'all were right. It's 5. Okay? Still with me? All right, let's see if we can't complicate this up a little bit. 12 and 13 say find the range for the measure of the third side of a triangle given the measures of two sides. All right, now we're about to have to do some work here. We know, let's just go ahead and call that third side x to have something to call it. All right? We know that we get 3 inequalities that must be true. Let's write those out, and then I'll show you how to figure out what the range of possible values is. Okay? And well, before I even do that, let me convince you that there is a range. If x was 10 million, that's too big, right? 4 plus 8 is not greater than 10 million. So there has to be some upper limit for how big x can be. And don't we also know, like for instance, if x was 0.2, that's too small because 0.2 plus 4 is not greater than 8. So there has to be a lower limit as well, doesn't there? So there is a range in there somewhere where we can use these 3 sides or 3 segments to make a triangle. And if I convinced you that there is a range, now here's how you find it. So 4 plus 8 has to be greater than x. The triangle inequality theorem says so. So 12 has to be greater than x. Now, usually, we like inequalities better when the x is on the left side. Now, if I do that, remember the alligator eating the bigger number, or Pac-Man eats the bigger number? So alligator's eating 12, so alligator's still eating 12. Okay? Well, not only does 4 plus 8 have to be greater than x, doesn't 4 plus x have to be greater than 8? Subtract 4 from both sides, x has to be greater than 4. And our third inequality is what? What's the combination I haven't done yet? 8 plus x has to be greater than 4. Well, you subtract 8, you get that. Well, again, that one doesn't really tell us anything, does it? We know x has to be greater than negative 4. You can't have a negative segment length. So the one in red's not incorrect. It's just not useful. But look at the black one and the blue one. X has to be greater than 4, but it has to be less than 12. I want you to write what's called a compound inequality. Okay? With the compound inequality, we always use less than signs. So, even though we like to have x on the left, since a compound inequality always uses less than signs, that x is greater than 4, I need to turn that into 4 is less than x. A compound inequality always uses less than signs. Look what I can do now. If I take that inequality and that inequality, look what it says. The black one says 4 is less than x, and the blue one says x is less than 12. Here's the compound inequality. 4 is less than x, and x is less than 12. That's the way I want you to write your range. Okay? Now, these are not less than or equal to signs. They're less than signs. So 4 and 12 are not actually in the range, are they? Numbers between 4 and 12 are in the range. Not 4, not 12, but all of the numbers between 4 and 12, including all the fractions and all the decimals. All right? Does that make sense? All right, let's do number 13 the same way. We know, if we let our third side be x, that the triangle inequality theorem says that 5 plus 11 is greater than x, which is 16 is greater than x. We want less than signs, so we make that x is less than 16. We also know that the triangle inequality theorem says that 5 plus x is greater than 11. And when we solve this one by subtracting 5 from both sides, we get x is greater than 6. We learn from the one we just did, and we think, oh, we want less thans. 6 is less than x. And this last one. We also know that 11 plus x has to be greater than 5. Subtract 11 from both sides, and we get one that's not useful. We already knew x had to be greater than negative 6. That doesn't tell us anything we didn't already know. Now, put together the black one and the blue one, and our compound inequality will be 6 is less than x, and x is less than 16. All right, you ready to have your mind blown? Be prepared. Everybody ready? Brace yourself. Look at number 12. Go back to number 12. What's 4 plus 8? What's 8 minus 4? Look at number 13. Look at the size they give you. What's 5 plus 11? What's 11 minus 5? Sweet, huh? All right. So, not only do you know the right way, you also know the easy way. And you're allowed to use the easy way until you get to ones like this. All right, on number 20, we're actually going to need to write out all three inequalities and work them out, because these aren't just numbers with one unknown side length. We don't know the length of any of these sides because they're all variable expressions. So, according to the triangle inequality theorem, I know that 2x plus 22 plus 5x minus 7 is greater than x plus 5, don't it? And in a minute, I'm going to come back and solve them. But I'm going to write all my inequalities out first. I also know, because of the triangle inequality theorem, that 2x plus 22 plus x plus 5 is greater than 5x minus 7. Right? Now, what's the two sides I haven't added together yet? All right, so x plus 5 plus 5x minus 7, that must be greater than 2x plus 22. Everybody with me? All right, let's solve these inequalities. Judging from what we did on 12 and 13, one of them is likely to not be useful. Let's see if that holds, okay? So let's see. Let's do the one in black over here on the left. So let's simplify before we solve. 2x plus 5x, that's 7x. 22 minus 7, positive 15, greater than x plus 5. Now let's subtract x from both sides. 6x plus 15 is greater than 5. Subtract 15 from both sides. 6x is greater than negative 10. Divide by 6, that'd be negative 10/6, or reduce it, negative 5/3. That doesn't seem all that useful, does it? To know that x is greater than some negative number. We already knew x had to be greater than a negative number. All right, so let's go to the blue one. Simplify before you solve. 2x plus x is 3x. 22 plus 5 is 27. Is greater than 5x minus 7. All right, let's subtract 3x from both sides. 27 is greater than 2x minus 7. Add 7 to both sides. 34 is greater than 2x. Divide both sides by 2. 17 is greater than x. But we tend to like less than signs, don't we? How'd that do what? Okay. Still with me? All right. Try the red one. X plus 5x, that'd be 6x. 5 minus 7, that's negative 2. Is greater than 2x plus 22. Let's subtract 2x from both sides. 4x minus 2 is greater than 22. Let's add 2 to both sides. 4x is greater than 24. Let's divide both sides by 4. X is greater than 6. We like less than for our compound inequality. 6 is less than x. So, the x is greater than negative 5/3 doesn't come into play, does it? But those other two give us the range. So as a compound inequality, 6 is less than x. X is less than 7. Okay, any questions? Add them to get the big number, subtract them to get the little number. All right, 28. Let's hustle up here. I want to get this done. 28. Same direction. Find the range. All right. So, since one of our sides, if that was just an x, we'd be okay. But it's not just an x. It's an x minus 2. So, x minus 2 plus 10 needs to be greater than 12. X minus 2 plus 12 needs to be greater than 10. And 10 plus 12 needs to be greater than x minus 2. Let's see, on the left here, that'd be x plus 8 is greater than 12. So x is greater than 4. We tend to like less than. So 4 is less than x. Try the one in the middle. X plus 10 is greater than 10. X is greater than 0. Is that helpful? Not really. We already knew x had to be greater than 0, because look, if it was 0, the length of that side right there would be negative, wouldn't it? So we know that can't happen. So we already knew that. And then in the red, 22 is greater than x minus 2. So 24 is greater than x. We prefer less thans. So x is less than 24. So as a compound inequality, 4 is less than x, and x is less than 24. All right. Number 39. Determine whether the given coordinates are vertices of a triangle. We don't even know the lengths of the sides. So what are we going to do? Distance formula. So the length of FG equals x2 minus x1 quantity squared plus y2 minus y1 quantity squared. All right, 3 plus 4 is 7. 7 squared is 49. Negative 3 minus 3 is a negative 6. Square that, I get 36. That's the square root of 85. Then I find the length of GH. Equals, that'll be 4 minus 3 quantity squared plus 6 minus negative 3 quantity squared. 4 minus 3 is 1. 1 squared is 1. 6 plus 3 is 9. 9 squared is 81. That's the square root of 82. And then last, the length of FH equals the square root of 4 minus negative 4 quantity squared plus 6 minus 3 quantity squared. All right, 4 plus 4 is 8. 8 squared is 64. 6 minus 3 is 3. 3 squared is 9. That's the square root of 73. Now, use your calculator to see if the inequalities work out. Because right now, we don't have to be able to simplify radicals. All right, so the two shortest are the square root of 73 and the square root of 82, right? So look, just do the square root of 73. And then on some calculators, you have to close the parentheses there or hit the next arrow button, whichever yours needs, plus the square root of 82. And I get that. Well, the square root of 85, square root of 81 is 9. So the square root of 85 is a little bit bigger than 9. So is 17.599388888 bigger than something a little bit bigger than 9? Yeah. And so if the two shortest are greater than the longest, are all the inequalities going to work? Yeah. So, yes, and our explanation is the square root of 73 plus the square root of 82 is greater than the square root of 85. Sorry I rushed that last one, but there's the assignment.